First I will discuss the concept, then I will solve one by one all the questions. Factors and multiples. Factors and multiples. Factors and multiples. First of all, let us define what is a factor, what is a multiple. What is a factor? Suppose I took a number 6. 6 is divided by some natural number. 6 is divided by some natural number, and the remainder it is 0. Remainder it is 0. Then x is said to be. Then x is a factor of 6. Then x is a factor of 6. X is a factor of 6. A number when divided by any other number, if the remainder it is 0, if the remainder it is 0, if the remainder if it is 0, then that number in the denominator is called a factor. That number is said to be a factor. Always in our NCERT textbook, factors are always a subset of natural number. So take from natural number. 6 when divided by which all numbers, remainder will be 0. 6 by 1, 1 6 are 6, so 1 is a factor. 6 is divisible by 2, 6 is 2 into 3. 6 is divisible by 3. 6 is divisible by 6. 1, 2, 3, 6. 1, 2, 3, 6. First important given point, a factor is always less than or equivalent to given number. A factor is always less than or equivalent to given number. A factor is always less than or equivalent to given number. This is the definition of a factor. This is the definition of a factor. What is a multiple? What is a multiple? Suppose multiple is present in the denominator. N divided by 6 it is 0. Let me call it as P, therefore, because there might be a confusion with the number. P divided by 6 it is 0. Then P is a multiple of 6. P is a multiple of 6. P is a multiple of 6. Any number if it is perfectly divisible by 6. Any number when it is perfectly divisible by 6. And perfectly divisible means remainder is 0. Perfectly. 4 is perfectly divisible by 2. Remainder 0. 8 is perfectly divisible by 2. Remainder 0. If P is perfectly divisible by 6, and that means remainder is 0. So P is a multiple of 6. P is a multiple of 6. 6 is perfectly divisible. 12 is perfectly divisible. 18 it is perfectly divisible. 18 it is perfectly divisible. Multiple is always greater than or equivalent to n. Multiple is always greater than or equivalent to n. Factor means the number which is less than a given number, right? And perfectly divides the given number. That is called the factor. The number which will perfectly divide a given, perfectly divide. X is dividing 6. Here P is getting divided by 6. I hope it is clear. One is the mathematical definition for a factor. Another is a mathematical definition for multiple. Factors and multiples. I hope the definition it is clear. Factor is always less than or equivalent to n. Factor is always less than or equivalent to n. If I take a natural number, factor is always less than or equivalent to given number. That means if I take a number 20, factors and multiples are from a set of natural numbers. From 1 to 20, there are certain numbers which will divide 20. Can I count it? Definitely yes. Can I count it? Because lower limit it is 1, upper limit it is 20. Between 1 to 20, which all numbers are the factors of 20? Can I count it? Yes. Multiples of 20. Lower limit is 20, upper limit I don't know, because in a natural number lower limit it is 1, which I know. Upper limit it is countable infinite. So in multiple related thing, the set is an infinite set, but in a factor related thing, the set is a finite number of sets. So we will focus more on the factors. I hope the idea it is clear. Definition of factors and multiples. Second important key point. Second important key point. I will go very slowly, very steadily, structured way. At the end of the class, you will be very good in factors and multiples. Suppose if I take a number 6, what are the factors of 6? What are the factors of 6? Let me write down. Factors of 6 are 1 is a factor of 6, 2 is a factor of 6, 3 is a factor of 6, 6 is a factor of 6. Factor of 6 are 1, 2, 3 and 6. Factor of 6 are 1, 2, 3 and 6. Now listen carefully. Can I count it? Yes. How many factors are there? 4 are there. For a simple natural number, I can write it and count it. As the value of the natural number increases, the number of factors may also get increased. So counting is ideally not the right process. Here I am listing all the factors, I am counting it. I am listing all the factors. That means like this, I am counting and coming back. Is there any process where I can count the factors directly? Yes, there is a process. What is the process to find out the number of factors for a given number? The given number, it is 6. The given number, it is 6. The given number, it is 6. 6 is a composite number. 6 is a composite number. Every composite number is derived from prime number. A prime numbers are the basic numbers. Any composite number is derived from prime numbers. 2 is a prime number. It cannot be broken further. 6 can be broken into 2 and 3. 12 can be broken into 2 into 6 and 3 into 4. The number which can be broken into smaller parts is called a composite number. Again, I am repeating. You take a number, if it can be broken into a smaller parts, till which you cannot break it, that number is called a composite number. Composite number. Composition means some more numbers are hidden in that number. 6 is a composite number. It is 1 into 6, 2 into 3. I hope the idea it is clear. Name itself is telling. So step number 1. Write the number as a power of prime basis. 6 can be written as 2 into 3. 6 can be written as 2 into 3. I am writing the factor starting from 1. 1 is a power 0. So write all the powers of 2 starting from 0 to 1. Why? Because 6 contains power of 2 as 1. Here also it is 3 power 0, 3 power 1. 3 power 0, 3 power 1. Now if you observe carefully, 2 power 0 into 3 power 0, 1 into 1, 1. 1 is a factor of 6. 2 power 0, 1. 1 into 3. 3 is a factor of 6. 2 into 1, 2. 2 is a factor of 6. 2 into 3, 6 is a factor of 6. 6 is a factor of 6. That means if a number is 6, 6 can be written as 2 power 1 into 3 power 1. I started from 0 because the factors starts from 1 onwards. So 2 power 0 to 2 power 1. So 3 power 0 to 3 power 1. Every power of 2 power 0 multiplied with every power of 3 power 0. I will get a factor. 2 power 0 into 3 power 0. 1 is a factor. 2 power 0 into 3 power 1. 3 is a factor. 2 power 1 into 3 power 0. 2 is a factor. 2 into 3, 6. 6 it is a factor. So totally how many combinations? 1 combination, second combination, third combination, 4 combination. Totally how many factors are there for this number? 4. Totally how many factors are there for this number? 4. This can also be written as from 0 to 1, how many cases are there? 2 cases. From 0 to 1, how many cases are there? 2 cases. First I will take all the cases of 2, then I will take all the cases of 3, one after the other. If one event is happening after another event, then it is fundamental principle of multiplication. Then it is fundamental principle of multiplication. Here I took all the powers of 2, 2 cases. Here I will take all the powers of 3, 2 cases. This is taken after this one. So 2 into 2, 4 cases. 2 into 2, 4 cases. This is a smaller number. This is a smaller number. Let me take a larger number. N equivalent to 2 cube into 5 square. n equivalent to 2 cube into 5 square. This is the number. 200, it is the number. 200, it is 25 into 8. I took a number n equivalent to 8 into 25, which is 200. Always remember, if the given number, if it is a composite number, write the number as a power of prime basis. We will write that point in hurriedly. Please do not do for composite number directly. Composite number, first thing is, write down it as a power of prime basis. Sir, why are we writing it as a power of prime basis? So that I cannot further divide it. Composite number is a derived number from prime number. Composite number is a derived number from a prime number. N equivalent to 2 cube into 5 square. Just now we studied, whenever we are finding the factors of a number, we will start with lowest power, which is 2 power 0. 1 is the lowest factor for any number, and I require till 2 power 3. Then I will go to the next number, 5 power 0 to 5 power 2. 5 power 0 to 5 power 2. 0 to 3, there are 4 cases. 0 to 2, there are 3 cases. 4 into 3, 4 into 3. Totally, how many factors are there for this number? 12 factors are there for this number. How many factors are there for this number? 12 factors are there for this number. 0 to 3, 4 cases. 0 to 2, 3 cases. 4 into 3. So totally, there are 12 factors for this number. 12 factors for this number. Hold on, sir. Here there are 4 factors for this number. In these 4 factors, I am seeing some odd numbers. Yes or no? I am seeing some even numbers. Yes or no? I will see some numbers which are a multiples of k. I will see some numbers which are not multiples of k. I will see some perfect squares. Suppose 8 into 25, 200. 1 is a factor, 2 is a factor, 4 is a factor, 5 is a factor, 8 is a factor, 10 is a factor, 15 is a factor, 16 it is a factor, 200, right? 20 it is a factor. Are you all with me? 25 it is a factor. 25 it is a factor. 50 it is a factor. 100 it is a factor. 200 also it is a factor. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if you see here, is there any case that we did it? Now if you see here, 1 is a factor, 2 is a factor, 4 is a factor, 5 is a factor, 8 is a factor, 10 is a factor, 15, 200 is not divisible by 15. This case we should not take. 16 is 16 a factor. 16 is 2 power 4. This case we should not take. 200 it is a factor. 25 8s are, 54s are, 100 2s are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means one more factor which is missing. Let us see what is that factor. 40, it is also a factor of 200. I hope you are understanding. Whenever you are counting and writing, there are some cases which are not divisible, you might write. There are some cases which you might miss it out. So that is the reason. Just to tell you, writing all and counting it, probably there are chances that you will miss the cases. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12 cases we got. In these 12 cases, there are some numbers which are perfect squares. 4 is 2 square. 100 is 10 square. There are some numbers which are odd numbers. There are some numbers which are multiples of 5. There are some numbers which are multiples of 4. So, that total collection of factors, there are some even factors, odd factors, perfect square factors, non-perfect square factors, perfect cube factors, total variety of questions that can be formed. That is the reason this question is developed. All these questions are developed based upon this understanding. Total, out of the total number of factors, there could be many factors which are odd, which are even, factors which are perfect squares, factors which are not perfect squares, factors which are multiples of 4, factors where the unit digit is 5, like that, so on and so forth. I hope the concept is clear. Everybody, I hope you understood the basic foundation of factors. Now let us take a question. Suppose, for example, n equivalent to 144. 144, it is a composite number. 144, it is a composite number. So this can be written as 2 power 4 into 3 square. 16 9s are 144. Listen carefully, sir. Once you understand this example, then we will solve that questions one by one. N is 144. 144 is 2 power 4 into 3 square. So first one, find the total number of, first question, find the total number of factors. Find the total number of factors. Factors means 1 is the first lowest factor from 0 to 4. How many cases? 5 cases. Here from 0 to 2, how many cases? 3 cases. 5 3s are 15. Totally, how many factors are there for this number? 15 factors are there for this number. First question, I hope it is clear. Second one, how many prime factors are there for this number? How many prime factors are there for this number? Third one, how many composite factors are there for this number? How many prime factors are there for this number? How many composite factors are there for this number? What do you mean by prime factors? Factors which are prime numbers. Factors which are prime numbers. What is a prime number? How many prime bases are there? 2 power 0. 2 power 0 is 1. 1 is neither prime nor composite. Sir, why 1 is neither prime nor composite? Why 1 is neither prime nor composite? 1 is neither prime nor composite. Why? Because depending upon the factors, natural numbers are divided into 3 types. Depending upon the factors, natural numbers are divided into 3 types. The first type is if a number has got exactly 2 factors. If a number has got exactly 2 factors, then that number is called a prime number. If a number has got exactly 2 factors, what are that exact 2 factors? 1 and the given number. If a number has got greater than 2 factors, any natural number has got greater than 2 factors, then it is called composite number. A composite number is a number which has got greater than 2 factors. A composite number is one which has got greater than 2 factors. If a number has got only 1 factor, then it is called neither a prime number nor a composite number. So 1 is neither prime nor composite. I hope the idea it is clear. 1 is a number which has got only 1 factor. A composite number will have greater than 2 factors. A prime number will have exactly 2 factors. A prime number will have exactly 2 factors. Depending upon the number of factors, if a number has got exactly 2 factors, it is called a prime number. If a number has got greater than 2 factors, it is called a composite number. If a number has got only 1 factor, it is neither a prime number nor a composite number. Now listen carefully. All are very conceptual questions, sir. Prime factors. What do you mean by prime factors? Factors which are prime numbers. 2 power 4 into 3 square. 2 power 0, 1. 1 is neither prime nor composite. 2 power 1, 2 is a prime number. Yes, right. 2 power 2, 4. 4 is not a prime number. Any power of 2 greater than 1, it is not a prime number. 2 cube, no. 2 power 4, no. Only 2 power 1. Similarly, 3 power 0, 1 is neither prime nor composite. 3 power 1, 3 power 1, it is 3. So 3, it is a prime factor. 3 square, no. So 2 and 3. That means single power of a prime number will give you prime factor. Single power of a prime number will give you prime factor. How many prime factors are there? 2 prime factors are there for this number. What are the 2 prime factors? 2 power 1 and 3 power 1. I hope the idea it is clear. Just visualize it. I got 2 power 4, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 2, 4 composite. 2 power 3 composite. 2 power 4 composite. 2 power 0, 1. 1 is neither prime nor composite. So the only case left is 2 power 1. Oh, similarly, the next component it is 3 power 2. 3 power 0, 3 power 1, 3 power 2, 3 power 2, 9, it is a composite number. 3 power 0, it is neither prime nor composite. So remaining it is 3 power 1. 2 power 1 plus 2 power 1 comma 3 power 1. So I want composite factors. I want composite factors. See, one is neither prime nor composite. Another is total set of prime numbers. Another is total set of composite numbers. This will give you total natural numbers. So if you add factors on the left hand side and the right hand side, 1 plus prime factor plus composite factor is equivalent to total factors. 1 plus prime factor plus composite factor, it is equivalent to total factors. Total factors, how many are there? 15. Prime factors, how many are there? 2. 1 plus 2, 3. 15 minus 3, it is 12. Remember, very, very important key point. 1 plus prime factors. 1 plus prime factor plus composite factors, it is equivalent to total number of factors. 1 plus prime factor plus composite factor, it is equivalent to total number of factors. I hope the idea it is clear. In this one, what we discussed, how to find out the factors we discussed, how to find out the prime factors we discussed, how to find out the composite factors we discussed. I hope these 3 idea it is clear. Same example we take. Same example. N equivalent to 2 power 4 into 3 square. 2 power 4 into 3 square. Find the total number of. Find the total number of. Find the total number of. Now listen carefully. Now listen carefully. First one, even factors. First one, even factors. Next one, odd factors. Even factors. Odd factors. I'll put a line here. Same variety. Factors which are multiples of 3. Factors which are multiples of 3. Factors which are multiples of 3. Next one, factors which are not multiples of 6. Factors which are not multiples of 6. Factors which are not multiples of 6. Let us discuss this concept. There is a number 144. 144, it is a composite number. I wrote the number as a power of prime basis, 2 power 4 into 3 square. In that number, there are some factors which are even. I need to count it. There are some odd factors. I need to count it. Then another variety. Now listen carefully. Listen carefully. Then there is a number 2 power 4 into 3 square. Find the total number of even factors and odd factor. What do you mean by an even number? What do you mean by even factors? What do you mean by even factors? Factors which are even numbers. Factors which are even numbers. What do you mean by an even number? Even number is a number which is divisible by 2. Factors which are even numbers are called even factors. Factors which are divisible by 2. Any number which is divisible by 2 is of the form 2 into something. Any number which is divisible by 2, it is of the form 2 into something. So this will be 2 into 2 cube into 3 square. 2 into 2 cube into 3 square. Why I took 2 into something? Why? Because it's an even number. It's an even number. Any even number is a number which is perfectly divisible by 2. Even number is a number which is perfectly divisible by 2. So any number which is divisible by 2 is of the form 2k. So 2 into, remaining it is 2 cube into 3 square. Remaining it is 2 cube into 3 square. These are the numbers which are getting multiplied by 2 and becoming an even factor. How many factors are there for this number? From 0 to 3. Why we should start with 0? Because 1 is the lowest factor for any number. 0 to 3, 4 cases. 0 to 2, 3 cases. 0 to 2, 3 cases. 4 3s are 12. 4 3s are 12. Very conceptual. Even factor. The same question can also be asked like this. Even factor, factors which are divisible by 2. Factors which are divisible by 2. Factors which are divisible by 2. Or factors which are multiples of 2. Factors which are multiple to. The same concept can also be extended to point C. Factors which are multiples of 3. Factors which are multiples of 3. Any multiple of 3 is written as 3 into something. Any multiple of 3 is written as 3 into something. So 3 into, remaining it is 2 power 4. 3 square already 3 we wrote. So what is there in the bracket? 3 power 1. These are the numbers which are getting multiplied by 3. These are the numbers which are getting multiplied by 3. And therefore factors which are multiples of 3. 5 2s are 10. 5 2s are 10. Are you all with me? 5 2s are 10. Factors which are multiples of 2, it is an even number. Factors which are multiples of 3, it is 3 into some natural number. Factors which are multiples of 5, it is 5 into some natural number. Factors which are not multiples of 10, that means total factors minus factors which are multiples of 10. We will use a negation approach. We will use a negation approach. Now see, odd factors. I want odd factors. There are two ways to do odd factors. It is total factors minus total number of even factors. Total factors. TF stands for total factors. TEF stands for total number of even factors. Total factors are 15. Total number of even factors are 12. 15 minus 12, it is 3. 15 minus 12, it is 3. This is one approach. This is one approach. Odd factor. Odd factor means, see, even number plus odd number. Even number plus odd number combination, it is a natural number. When you add in even numbers and odd numbers, you will get a natural number. So when you add even factors and odd factors, you will get the total number of factors. Total number of factors is always equivalent to even factors plus odd factors. Total number of factors is always equivalent to even factors plus odd factors. So total 15 minus 12, it is 3. Another way to look at this question is, it is an odd factor. It is an odd factor. It is an odd factor. Odd factor means it is not divisible by 2. Not divisible by 2. Odd number will never be divisible by 2. Odd number. Odd number is a number which is never divisible by 2. Odd number is a number which is never divisible by 2. So n equivalent to 2 power 4 into 3 square. It is never divisible by 2. Eliminate all the powers of 2. Eliminate all the powers of 2. So 3 power 2, which all combinations? 3 power 0, 3 power 1, 3 power 2. Total how many combinations I got? Three combinations I got. Odd number is a number which is never divisible by 2. Whenever you are finding out the odd factor, remove all the powers of 2. Why? Because odd number will never be divisible by 2. Odd number will never be divisible by 2. I hope the idea it is clear. Similarly, factors which are not multiples of 6 is total factors minus factors which are multiples of 6. Total factors are 15 minus multiples of 6 is 2 into 3. Remaining it will be 2 cube into 3 power 1. It is 6 into something. Are you all with me? So how many are there? 4 into 2, 8. 15 minus 8. It is equivalent to 7. 15 minus 8, it is equivalent to 7. Is the idea very clear to you? Total factors which are not multiples of 6 is total factors minus factors which are multiples of 6. Total factors minus factors which are multiples of 6. So 15 minus 4 into 2, 8. 15 minus 8, it is 7. 4 questions, it is clear, right? Even factor, odd factors, factors which are multiples of 3 and factors which are not multiples of 3. I hope the idea it is clear. Another model. One by one, first we will understand the concept, then we will solve the problems very, very fast. If the question is n equivalent to 2 power 4 into 3 square. N equivalent to 2 power 4 into 3 square. Find the total number of factors. Find the total number of factors which are. Find the total number of factors which are perfect squares. Find the total number of factors which are perfect squares. Find the total number of factors which are non-perfect squares. Which are non-perfect squares. Find the total number of factors which are perfect cubes. Find the total number of factors which are non-perfect cubes. Another variety which we will discuss. First 15-20 minutes. Once the concepts are clear, then we can solve the problems very, very easily. Find the total number of factors which are perfect squares, which are non-perfect squares, perfect cubes and non-perfect cubes. Concept. What do you suppose? If the power is an even number, if the power of any number, if it is an even number, including 0, if the power of a natural number, it is an even number, including 0, then the number is called a perfect square. Then the number is called a perfect square. Perfect square means a number multiplied by itself. 16 is a perfect square. It can be written as 2 power 4. 4 is an even number. It can be written as 4 square. 2 is an even number. If you can write a number where the power is an even number, including 0, then the number is a perfect square. Then the number is a perfect square. Power should be an even number, including 0. Once you understand this concept, then you can solve this problem very, very easily. N equivalent to 2 power 4 into 3 square. N equivalent to 2 power 4 into 3 square. Now listen carefully. Power should be an even number. 2 power 0, 2 power 2, 2 power 4. Are you all with me? I cannot take 2 power 1 and 2 power 3 because power should be an even number, including 0. 3 power 0 and 3 power 2. 3 power 0 and 3 power 2. 2 power 0, 2 power 2, 2 power 4. 3 power 0, 3 power 2. Hey Anil sir, why you have not taken 2 power 1? Not possible. Sir, why you have not taken 2 power 3? Not possible. If I want the factors which are perfect squares, if I want the factors which are perfect square, power should always be an even number, including 0. 4 into 9, 36, it is a perfect square. 16 into 1, 16, it is a perfect square. 1 into 9, 9, it is a perfect square. So totally how many cases are there? 0 to 4, 3 cases are there. Similarly, for 3 power 2, how many cases are there? 2 cases are there. 3 2s are 6. Totally, there are 6 factors which are perfect squares. Why these 3 cases? 1, 2, 3. What are these 3 cases? 2 power 0, 2 power 2, 2 power 4. Or, in simple language, divide the power by 2. Divide the power by 2 and add 1. Divide the power by 2 and add 1. Sir, why are you dividing the power by 2? Power should be an even number. Even number, it is perfectly divisible by 2. Even number, it is perfectly divisible by 2, including 0. That is the reason 0 is included. We are adding 1. Perfect square means power should be an even number, including 1. Even number means it is divisible by 2. So 4 divided by 2. I will get 2 cases. What are the 2 cases? 2 power 2 and 2 power 4. What is the another case? Power can also be 0. That is the reason we are adding 1. The power can be any number. If you are getting a decimal value, please ignore the decimal value. Please ignore the decimal value. If the question is 2 power 17 into 3 power 5, factors which are perfect squares. Factors which are perfect square is 17 by 2, 8.5. Ignore decimal. 8 add 1. 5 by 2, 2.5. 2 plus 1. So this will be 9 into 3. Total 27 factors are perfect square. Divide the power by 2 and add 1. This example is important. Why I took only 8? In 2 power 17, what are the cases? 2 power 2, 2 power 4, 2 power 6, 2 power 16. 2 power 2, 2 power 4, 2 power 6, 2 power 16. 2 1s are 2, 2 8s are 16. 8 cases, why am I adding 1? 2 power 0. 1 is a factor for any number. Divide the power by 2 and add 1. Divide the power by 2 and add 1. First concept can also be used in third concept. First concept can also be used in third concept. First concept is divide the power by 2 and add 1. Why? Perfect square means power should be divisible by 2. Perfect cube means power should be divisible by 3. Power should be divisible by 3 and add 1. Perfect square means power should be divisible by 2 and add 1. Perfect cube means power should be divisible by 3 and add 1. So same thing. Divide the power by 3 and add 1. Divide the power by 3. Divide the power by 3 and add 1. Divide the power by 3 and add 1. Are you all with me? So 4 by 3, 1 plus 1, 2. 2 by 3, 0 plus 1, 1. So 2 1s are 2. Perfect square means divide the power by 2 and add 1. Perfect cube means divide the power by 3 and add 1. Similarly, non-perfect square means total factors minus factors which are perfect squares. Total factors minus factors which are perfect squares. If I want non-perfect cube means total factors minus factors which are perfect cubes. I hope this concept is also clear. Whenever you get non, it is very easy. No is a negation. Total minus what is there with us will give us what is pending. Factors which are non-perfect square means total factors minus factors which are perfect squares. Non-perfect cube means total factors minus factors which are perfect cubes. I hope these 4 concepts are very clear. Perfect square, non-perfect square. Perfect cube, non-perfect cube. Even factors, odd factors. Factors which are multiples of 3. Factors which are not multiples of 3. Factors, prime factors and composite factor. One is neither prime nor composite. One is neither prime nor composite. Any doubts are there? I think it is perfect. I hope no issues. All these concepts are clear. Once the concepts are clear, then we will get into a problem solving. One by one, A to I, we will try to solve the problem. First we will do till this one. Then again K and L I will discuss. K and L I will discuss. Till H we discussed the concept. Factors we discussed, odd factors we discussed, even factors we discussed, composite factors we discussed, multiples of 5 we discussed, 15 we discussed, factors which are perfect square we discussed, perfect cube we discussed. First we will solve from A to H, then again a concept related to I and J, then we will solve the questions related to K and L. One by one we will solve the problems. One by one. Find the total number of factors for n. Listen carefully. These number should be a power of prime basis. Yes, it is given already. If it is a composite number, write the number as a power of prime basis. Factors will be 0 to 5, 6, 0 to 4, 5, 0 to 3, 4. 6 5s are 30, 34s are 120. 6 5s are 30, 34s are 120. First one 120. Second one, find the total number of factors which are odd. Odd number means it is not a multiple of 2. Close all the powers of 2. 0 to 4, 5 cases. 0 to 3, 4 cases. 5 4s are 20. Second one, answer is 20. Third one, factors which are even numbers. Total factors minus factors which are odd. I will get a factors which are even. Third one, answer is 100. Third one, answer is 100. Fourth one, listen carefully. What is the question? That fourth one is, find the total factors which are composite. Find the total factors which are composite. 1 plus prime factors plus composite factor is equivalent to total factors. 1 plus prime factors plus composite factors. PF stands for prime factors. CF stands for composite factors. 1 plus prime factors plus composite factors is equivalent to total factors. 1 plus, how many prime bases are there? 2, 3 and 5. Plus composite factors is equivalent to 120. 120 minus 4. Answer for this question, it is 116. Answer for this question is 116. 1 plus a total number of prime factors. How many prime bases are there? 3. 1 plus 3 plus composite factors. It is equivalent to total factors. So total factors is 120. 120 minus 4 is 116. 120 minus 4 is 116. E. How many factors are there which are multiples of 5? Any multiple of 5 is 5 into k. 2 power 5 will be as it is. 3 power 4 will be there. 5 is taken out. Remaining it is 5 square. So 6 into 5 into 3. 6 into 5 into 3. 6 5s are 30. 33s are 90. Question E. Answer is 90. Question E, answer is 90. Question E, answer is 90. I hope the idea it is clear. Next one, I think factors which are multiples of 15. Factors which are multiples of 15. I am writing it down, sir. Any multiple of 15 is 15 into k. 15 is 3 into 5. Remaining it is 2 power 5. 3 power 1 it is taken out. Remaining is 3 power 3. 5 power 1 it is taken out. Remaining is 5 power 2. Remaining it is 5 power 2. Till here it is clear. 15. 15 it is 3 into 5. 3 is taken out. Remaining it is 3 power 3. 5 is taken out. Remaining it is 5 square. Here 2 power 5. So what will be the answer? 6 into 4 into 3. 24 3s are 72. Factors which are multiples of 15 are 72. Factors which are multiples of 15 are 72. So once we are good in concepts, we can solve question A, question B, question C, question D, question E, question F. Question F. Question F. I think from A to F, everything it is clear. Factors which are multiples of 15 are 15 into k. 15 is 3 into 5. Remaining part is 2 power 5, 3 power 3, 5 power 2. 6 into 4 into 3. Next one, from H to J, we will write down in a different slide. Factors which are perfect squares, that also we discussed. So n equivalent to 2 power 5 into 3 power 4 into 5 power 3. 2 power 5 into 3 power 4 into 5 power 3. What is the question? Factors which are perfect squares. Factors which are perfect squares. Factors which are perfect squares. Perfect square means divide the power by 2 and add 1. Do not worry about decimal. 5 by 2, 2 plus 1. 4 by 2, 2 plus 1. 3 by 2, 1 plus 1. 3 by 2, 1 plus 1. 3 into 3 into 2. 9 2s are 18. 3 into 3 into 2, which is 18. Divide the power by 2. Divide the power by 2 and add 1. Factors which are perfect squares. Similarly, factors which are perfect cubes. Factors which are perfect cubes. Divide the power by 3 and add 1. 5 by 3, 1 plus 1. 4 by 3, 1 plus 1. Ignore decimal. 3 by 3, 1 plus 1. 2 into 2 into 2. 2 2s are 4, 4 2s are 8. 2 2s are 4, 4 2s are 8. Perfect square. What is the concept? Divide the power by 2 and add 1. Divide the power by 2 and add 1. Divide the power by 2 and add 1. What is the concept for perfect cube? Divide the power by 3 and add 1. Divide the power by 3 and add 1. Divide the power by 3 and add 1. Till here, I hope the concept it is clear. Which all questions we did? A, B, C, D, E, F. G, H also we did it. G, H also we did. I and J are one concept which we will do it. Then we will get into K and L. K and L. G, H. Till here it is clear. Please read the question I. Find the total number of factors where the unit digit it is 0. Unit digit it is 0. Unit digit it is 0. Now see here. Question is n equivalent to 2 power 5 into 3 power 4 into 5 power 3. Factors where whose unit digit it is 0. Factor where whose unit digit it is 0. Factors where whose unit digit it is 0. Whose unit digit it is 0. Now listen carefully. What is the smallest natural number whose unit digit it is 0? 0 cannot be taken. 10 can be taken. Next number 20. Next number 30. Next number 40. 100 unit digit 0. 1000 unit digit 0. Factor whose unit digit is 0 is nothing but a number which is a multiple of 10. Which is a multiple of 10. Are you all with me? Which is a multiple of 10. 10 can be written as 2 into 5. Remaining it is 2 power 4. Remaining it is 3 power 4. Remaining it will be 5 power 2. These are the numbers which are getting multiplied by 10. Any number when you multiply by 10, unit digit will be 0. Any number when you multiply by 10, unit digit will be 0. Are you all with me? Unit digit will be 0. Now, these are the numbers which are getting multiplied. So, answer will be 5 into 5 into 3. 5 5s are 25, 25 3s are 75. So totally, how many factors are there whose unit digit it is 0? 75 factors are there. How many factors are there whose unit digit it is 0? 75 factors are there. I hope the idea it is clear. Factor whose unit digit it is 0. Similarly, if the question is factors whose last two digits are 0 0. Factors whose last two digits are 0 0. Factors whose last two digits are 0 0. What we have to do is, in a natural number, what is the smallest natural number where the last two digits are 0, 0? 100 is one number, 200 is another number, 300 is another number. All these numbers are multiples of 100. All these numbers are multiples of 100. So it is 100k. 100 is 2 square into 5 square. Remaining it is 2 cube. It will be 3 power 4. It will be 5 power 1. These are the numbers which are getting multiplied by 100, and therefore the last two digits are 0 zeros. So what will be the answer for this one? 0 to 3, 4 cases, 0 to 4, 5 cases, 0 to 1, 2 cases. 22s are totally 40 factors are there whose last two digits are 0 zeros. 40 factors are there whose last two digits are 0 zeros. Whose unit digit is 0, whose last two digits are zeros. I hope the idea it is very clear. Suppose if we ask a question, factors whose last digit has only one zeros. Only one zero. Okay. Factors whose factors which has exactly one zero at the end. Factors which has exactly one zero at the end. Exactly 1 0 at the end. Factors which has exactly 1 0 at the end. Sir, what is the difference between this question and this question? Please think and tell me. Please think and tell me what is the difference between these two questions. Factors whose unit digit is 0. If one digit is 0, it can be 10, it can be 20, it can be 30, it can be 100, it can be 200, it can be 1000 and so on. But I want exactly 1 0. I want exactly 1 0. Exactly 1 0. That means it is factors which are multiples of 10. Subtract the factors which are multiples of 100. Because if I subtract the factors which are multiples of 100, 2 zeros, 3 zeros, everything will go away. See here, factors which are multiples of 10 are 10, 20, 30, 40, 100, 110, 120, 200 and so on. These are the total factors which are multiples of 10. If I delete the factors which are multiples of 100, all of them has got exactly 1 0 at the end. Factors which has got exactly 1 0 at the end is total factors which are multiples of 10 minus factors which are multiples of 100. Factors which has exactly 1 0 at the end is factors which are multiples of 10 minus factors which are multiples of 100. I hope this example will give a very good understanding of this concept. Suppose if the same question is factors which has exactly last two zeros at the end. Factors which has exactly last two zeros at the end. Exact last two zeros means, suppose if the same question is exactly last two zero. Exactly last two digits is 0. It is factors which are multiples of 100 minus factors which are multiples of 1000. I hope the concept it is clear. Factors which has got exactly two digits is 0. Very, very good question. This kind of questions regularly come in your various examination. I hope the idea it is clear. Suppose if the question is, there is a student who asked me a question, factors which has no zeros at the end. No zeros at the end is total factors minus factors which has at least 1 0 at the end. Same like what we did for a perfect square and a non-perfect square. Total factors minus factors whose unit digit is 0 will eliminate all the factors where the unit digit is 0. I hope the concept it is clear. Now let us go back and discuss this question. Which question it is? I find the total number of factors of n which has unit digit 0. Unit digit means, suppose, let me share it here. Unit digit 0. Did I do unit digit 0? Yes. Factors which has got unit digit 0 we discussed. What is the next one? Last two digits 0. Last two digits 0 also we discussed. Last two digits 0 also we discussed. 2 square into 5 square. Exactly 1 0 and whose unit digit will be 0. I hope you understood the subtle difference. Once you are good in concepts, you can start creating as many questions as possible. As many questions as possible. Next one. Let us see the question what we discussed. So these are all the concepts that we discussed. Any other questions pending in this one? Let me see the questions. Yes. Two more questions are pending. Find the sum of all factors of n. Find the product of all factors of n. Sum of factors and product of factors. Factors related. I hope the concept is clear. Again, I will repeat the concepts whatever we discussed. First, we understood what is the definition of factor. What is the definition of a multiple. How to find out the total number of factors. How to find the total number of odd factors, even factors, prime factors, composite factors, factors which are perfect squares, factors which are non-perfect squares, factors which are perfect cubes, factors which are non-perfect cubes, factors whose unit digit is 0 or the last two digits is 0. Now let us get into it. See, these are the factors. He is telling what will happen if I add these factors. What will happen if I add these factors? What will happen if I do product of the factors? What will happen if I do product of the factors? Now here we will do sum of the factors on the left hand side and product of the factors on the right hand side. Sum of the factors. Sum of the factors. Here we will do. And product of the factors also we will do here. First we will understand the concept. Problem by problem we will discuss. Product of the factors. Product of the factors. Sum of the factors as well as product of the factors. To get the concept, what I will do is I will take a random natural number. I will take a random natural number. Let me take a random natural number as 12. Random natural number, it is 12. What are the factors? A factor is a number which is less than or equivalent to given number. Perfectly divides. 1 is a factor of 12. 2 is a factor of 12. 3 is a factor of 12. 4 is a factor of 12. 6 is a factor of 12. 12 is a factor of 12. 12 is a factor of 12. What is he adding? Sum. Sum means add. Sum means add. Add all these factors and tell me the answer. Add all these factors and tell me the answer. N is 12. 12 is 2 square into 3 power 1. 2 square into 3 power 1. First write down. If the given number is a composite number, write the number as a power of prime basis. It is 2 square into 3 power 1. What are all the factors for this number? 2 power 0, 2 power 1, 2 power 2. What are the factors for this number? 3 power 0, 3 power 1. Let me see what is happening if I add all the powers of 2 starting from 0 to given power. 2 power 0 plus 2 power 1 plus 2 power 2. Then get into 3 power 0 plus 3 power 1. Then get into 3 power 0 plus 3 power 1. See what is happening. If I observe here, 2 power 0 is 1. 1 into 1, 1. Yes. Plus 2 power 1 into 3 power 0. It is 2. Yes. Then 3 power 1 into 2 power 0, it is 3. 1 plus 2 plus 3. Are you all with me? Again it is 2 power 1 into 3 power 1, it is 6. 2 square into 3 power 0, it is 4. 2 square into 3 power 1. 4 3s are 12. That means 1 plus 2 plus 3 plus 4 plus 6 plus 12. 1 plus 2 plus 3 plus 6 plus 12 can be written as 2 power 0 plus 2 power 1 plus 2 power 2 into 3 power 0 plus 3 power 1. That means the sum of the factors concept is, first take the number, write it down as a power of prime basis starting from 0 to 2. 2 power 0 plus 2 power 1 plus 2 power 2. 0 to 1. 3 power 0 plus 3 power 1. This is the concept for sum of the factors. For example, if the question is if the question is 3 cube into 5 power 4. If the question is 3 cube into 5 power 4, find the sum of the factors. Find the sum of the factors. Sum of the factors is given by, start from 0 to 3, 3 power 0 to 3 power 3. Again start from 0 to 4, 5 power 0 to 5 power 4. I hope the concept it is clear. This is the how sum of the factors will be calculated. By taking a simple example, I can prove that 12, the factors are 1, 2, 3, 4, 6, 12. 1 plus 2 plus 3 plus 4 plus 6 plus 12. It is equivalent to 2 power 0 plus 2 power 1 plus 2 power 2 into 3 power 0 plus 3 power 1. I hope the concept it is clear. Similarly, the same number if I take n is 12. What are the factors of 12? 1, 2, 3, 4, 6, 12. What are the factors of 12? 1, 2, 3, 4, 6, 12. These are all the factors of 12. Product means into. Product means I need to multiply. Sum means I need to add. Sum of the factors means I need to add all the factors. Product of the factors means I need to multiply. Just to get the concept right, I will multiply first and last. I will multiply second and second last. I will multiply third and third last. So this is nothing but product of the factors of n is 1 into 12 is 12. 2 into 6 is 12. 3 into 4 is 12. So it is 12 power 3. 12 is the original number. Out of 6 factors, half of them has given us the product. So number power, number of factors by 2. Number power, number of factors by 2. Product of the factors, very, very important concept. Product of the factors is given by the logic. Number power, number of factors by 2. Number power, number of factors by 2. Product of the factors is given by the concept. Number power, number of factors by 2. Sir, what if the number is a perfect square? It makes no difference. 36 factors are 1, 2, 3, 4, 6, 9, 12, 18, 36. 9, 12, 18, 36. Now if you listen carefully, 1 into 36, 36. 2 into 18, 36. 3 into 12, 36. 4 into 9, 36. These 4 has got 4 pairs whose product is 36. So 36 power 4. 6 can be written as 36 power 1 by 2. This will become 36 power 9 by 2. Number power, number of factors by 2. Number power, number of factors by 2. 36, totally 9 factors are there. 36 if I write down as prime basis, 2 square into 3 square. 2 square into 3 square. Totally 9 various factors are there. First 4 is combined with last 4. In between 6 can be written as 36 power 1 by 2. In between it can be written as 36 power 1 by 2. I hope the concept it is clear. Any doubts are there till here? Right. I hope it is perfectly clear. So product of the factors is given by number power number of factors by 2. Product of the factors is given by number power number of factors by 2. So what is the given question? Given question is n equivalent to 2 power 5 into 3 power 4 into 5 power 3. Am I right? Yes. So the number is 2 power 5 into 3 power 4. Number is given by 2 power 5 into 3 power 4 into 5 power 3. Sum of the factors. Sum of the factors is start from 2 power 0. 2 power 0, 2 power 1 till 2 power 5. 3 power 4 is 3 power 0, 3 power 1 till 3 power 4. 5 power 3 it is 5 power 0, 5 power 1, 5 power 2 plus 5 power 3. Calculation you can use geometric progression, sum to n terms in geometric progression and you can do it. This is sum of the factors. Product of the factors. Product of the factors is given by number power number of factors by 2. Number it is 2 power 5 into 3 power 4 into 5 cube. Number of factors is 6 into 5 into 4 divided by 2. 2 ones are 2 twos are. So this is product of the factors is given by the logic. Number power number of factors by 2. Number power number of factors by 2. I hope the concept is clear. Every question we will discuss one concept. Product of the factors is given by number power number of factors by 2. F stands for the total number of factors. 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 Till here, I think we solved entire question 1. How many questions are there in question 1? In question 1, how many concepts we discussed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 concepts we discussed in question number 1. Any doubts are there in these question number 1? Kindly keep your doubt in the comment section. 1 minute, I will look into the doubts. Any student who got a doubt, you can ask me, sir. Anybody who got any doubts, kindly ask me. Kindly ask me. Kindly ensure that everyone sits in the class with a notebook and a pen. Ensure that you attend all the classes. In case if you miss any of the classes, watch the recording of the classes. You got any academic doubt, kindly put it in the comment section. If the doubt is with respect to topic, I will be very happy to discuss it. For me, what is very important is my time investment in delivering the content is precious. Your investment of time in learning the content is precious. Absolutely no nonsense other than just an academic discussion. I hope all these concepts are clear. Everybody reply with yes if it is clear to you. Right? In case if you got a doubt, ask me. In case if you got a doubt, kindly ask me. In detail, we will discuss. In detail, thoroughly, we will discuss the concept. Is it clear, everyone? Is it clear? Factors which are perfect squares, not perfect squares, unit digit, how to find out the prime factors, odd factors, even factors, right? Sum of the factors and product of the factors. Then another, how many questions are there? 1, 2, 3, 4, 5, 6. 6 questions are there, concept based questions. I think first we will solve some easy questions, 2-3 questions. Find all the prime factors of 660. Find all the prime factors of 660. 660, it is a composite number. 6 into 110. 6 into 11 into 10. 10 it is 2 into 5. So here it is 2 into 3 into 5 into 11. 2 into 3 into 5 into 11. What are all the prime factors for this number? 2, 3, 5 and 11. 2, 3, 5 and 11. Third question easy. Whatever we discussed, how many factors of 350 are even? 350 are even. 350, it is a composite number. It is 50 into 7. 50, it is 5 square into 2 power 1 into 7. Any factor which is an even number, any factor which is an even number is divisible by 2. So 2 into, remaining it will be 5 square into 7 power 1. 5 square into 7 power 1. These are the numbers getting multiplied by 2. So therefore it is an even factor. How many factors are there for this number? 3 into 2. 3 into 2. Answer for this question is 6. Answer for this question is 6. Already we discussed this model. How many factors of 464 are divisible by 4? I want the factors which are divisible by 4. So it is 4 into 4 ones are 4, it is 116. These 116 factors are getting multiplied by 4. So 4 into, this is 2 square into 4 2s are 29. So these are the numbers getting multiplied. How many factors are there for this number? 3 into 2. 2 square means 2 power 0, 2 power 1, 2 power 2. 29 will be 29 power 0, 29 power 1. 29 power 0, 29 power 1. Idea clear? Next one. Okay, this is a new model. Any other questions are there? These are new model questions. Now, already this is a very easy question. Already we discussed 16n square plus 17n. 16n square plus 7n plus 6 divided by n. So this will become 16n plus 7 plus 6 by n. 6 by n. It is an integer. It is an integer. Anyway, this is an integer. This is an integer. 6 by n should be an integer. 6 by n should be an integer. That means n should be a factor of 6. N should be a factor of 6. This is basically a definition related question. I told you at the beginning the definition of factor. N divided by x. If n divided by x, a remainder is 0, then x is a factor of n. X is a factor of n. This is an integer, this is an integer, this is an integer. 6 by n should be an integer. That means n should divide 6. If n is not dividing 6, 6 by 5, I will get a decimal value. 6 by 7, I will get a decimal value. So what are the factors of 6? 1, 2, 3 and 6. 1, 2, 3 and 6. So how many values n can take such that this expression will be an integer? Answer is 4. Answer is 4. All these we discussed. What is the largest possible natural number for which the following expression would give a natural number? This expression output, it is a natural number. This expression output, it is a natural number. This expression output, it is a natural number. Let me divide 20 by 5, 4, 4n cube, 15 by 5, 3n square, 10 by 5, 2n, 5n by 5n, 1, 10 by 5n, it is 2 by n. This is a natural number. This is a natural number. If it is a natural number, all these are natural numbers. That means 2 should be divisible by n. What is the maximum natural number? N can take, n will take all the factors of 2. What are the factors of 2? 1 comma 2. Maximum value it is 2. Maximum value it is 2. 8th and 9th are similar model. 8th and 9th are similar model. Let me see if any other questions are there where we can discuss in detail. Other questions, any other questions? I think 19th question, it's an easy question. Numerator is greater than denominator. So 94 by 27 is 27 3s are 81. 27 3s are 81. Remaining it is 13. 13 by 27. So this can be written as 1 by 27 by 13. So this can be written as 1 by 13 2s are 26 plus 1. I hope it is clear. This is what given in the question. A plus 1 by B plus 1 by C. A value it is 3. B value it is 2. C value it is 13. 3 plus 2 plus 13. What will be the answer? 3 plus 2, 5. 5 plus 13, it is 18. 5 plus 13, it is 18. This is a very famous Repeated question. 19th is an easy question. So what we will do is, let me see. Let us get into another concept. I hope this idea it is clear. Now let me solve this entire A, B, C, D, E and F. How many questions are there? 6 questions are there. But before this question, let me discuss the concept. We will understand the concept. Then we will solve these problems one by one. One by one. First concept. Please write down the concept. Concept. Number of ways. Concept. Number of ways of writing a number. Number of ways of writing a number as a product of. Number of ways of writing a number as a product of. As a product of 2 factors. Number of ways of writing a number as a product of 2 factors. Number of ways of writing a number as a product of 2 factors. Now listen, there are 2 ways are there. Suppose product of 2 factors, product of 2 odd factors, product of 2 odd factors, product of 2 even factors, product of 2 even factors, product of 2 even factors, product of, all these concepts are very important, sir. Product of 1 even and another odd. Product of 1 even and another odd. One by one we will discuss. Product of 1 even and another odd. Number of ways of writing a number as a product of 2 factors, as a product of 2 odd factors, as a product of 2 even factors, product of 1 even and another odd. Last one is sum of 2 product of 2 coprimes. Product of 2 coprimes. Product of 2 coprimes. All these concepts we'll discuss. Number of ways of writing a number as a product of 2 factors, product of 2 odd factors, product of 2 even factors, 1 even, another odd, product of 2 coprimes. Now, I will discuss the concept on the right side. Listen carefully. Concept. Concept. Suppose if I take 12. Read the statement here. Number of ways of writing a number as a product of 2 factors. 12 can be written as 1 into 12 or 12 into 1. 2 into 6 or it can be written as 6 into 2. 3 into 4. It can also be written as 4 into 3. 4 into 3. So reverse also I am writing. That case is called as an ordered pair. That case is called as an ordered pair. What do you mean by an ordered pair? A into B is different from B into A. A into B, it is different from B into A. Then that is called ordered pair. Ordered pair means reverse can also be written. When will you use ordered pair? If the variables are present in the question. If the question contains variables. If variables are present in the question. If the variables are present in the question, I will make use of ordered pair. If variables are not present in the question, I will not make use of ordered pair. If the variables are present in the question, then it is an ordered pair. Not present in the question, then it is an unordered pair. I hope the idea it is clear. So in ordered pair, 12 it is 2 square into 3 power 1. 3 into 2, 6. 6 factors are there. First case, second case, third case, fourth case, fifth case, sixth case. That means in an ordered pair, number of ways of writing a number as a product of 2 factors, it is equivalent to total number of factors. It is equivalent to total number of factors. It is equivalent to Total number of factors. Where we are doing the case in ordered pair. What do you mean by ordered pair? The way in which you write the number matters. A into B is different from B into A. A into B is different from B into A. Number of ways of writing a number as a product of two factors, it is always equivalent to total number of factors. It is always equivalent to total number of factors. It is always equivalent to total number of factors. See the second case, product of two odd factors. What do you mean by odd factor? Factor which is an odd number. Odd number into odd number. What is odd number into odd number? Odd number. If the given question is an even number, then this answer is 0. Then this answer is 0. Are you all with me? I hope the idea it is clear. Odd into odd, it will be odd. But if the given question it is an even number, second one answer is 0. Third one, product of two even factors. Product of two even factors. Product of two even factors. A into B, it is equivalent to 12. A is even number, 2K1. B is an even number, 2K2. Equivalent to 12. So K1 into K2 is equivalent to 3. 3 can be written as 3 into 1 and 1 into 3. 3 means how many factors? 3 power 0, 3 power 1. 2 factors I will get. So decompose into 2K1 into 2K2 method and then try to solve. I hope the idea it is clear. Even factor, even number will be of the form 2K1. Another even number is of the form 2K2. 2 into 2, 4. 12 by 4, 3. K1 into K2, 3. So divide the right hand side by 4. How much ever it is remaining, that many factors find it out. 1 into 3, 3 into 1. What is D? D is nothing but total factors minus B plus C, it will give you D. One even, another odd. Total this one minus these two, I will get D. Product of two coprimes we will discuss. If variables are present in the question, then it is an ordered pair. If variables are not present in the question, then it is an unordered pair. Now let me discuss unordered pair. This classification is very important, sir. Variables are not present. Then I will use unordered pair. If variables are not present, then I will use unordered pair. If variables are present, I will use ordered pair. If variables are present, I will use ordered pair. I hope the concept it is very clear, right? So unordered pair. Just we will take a 10 seconds break and I will be back. 10 seconds break. Am I audible? Unordered pair. Unordered pair means variables are not present. Kindly let me know if I am clearly audible. Variables are present, I will use ordered pair. Variables are not present, I will use unordered pair. Now listen carefully. Now, unordered pair, same number will take case number 1. Case 1 is when the number is a non-perfect square. Case number 2, when the number is a perfect square. Case number 2, when the number is a perfect square. Case 1 when it is a non-perfect square. Case 2, it is a perfect square. Case 2, it is a perfect square. Remember, in an ordered pair, reverse case, it is a different case. Reverse case, it is a different case. In an unordered pair, reverse case, it is an equivalent case. Unorder, ordering does not matter. Ordering does not matter. Ordering does not matter. Now listen carefully. If it is 12, 1 into 12, 2 into 6, 3 into 4. So 12 is 2 square into 3 power 1. Totally how many factors? 6. Half of them are reverse. That half of them are eliminated. That half of them are eliminated. That is the reason in an unordered pair, if the number is a perfect non-perfect square, answer is number of factors by 2. Sir, why half came? The same thing has been duplicated in the reverse case. Reverse case we need to eliminate it. Reverse case we need to eliminate. Number of factors by 2. Number of factors by 2. If it is a perfect square, 36, 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 6 into 6. 36 is 2 square into 3 square. Totally how many factors we got? 3 3s are 9. In that 9 cases, these 36 into 1, 18 into 2, 12 into 3, 9 into 4 are eliminated. Because in an unordered pair, reverse is not possible. 36 into 1, 18 into 2, 12 into 3, 9 into 4 not possible. So it is number of factors plus 1 by 2. Number of factors plus 1 by 2. Number of factors are 3 3s are 9. 9 plus 1, 10. 10 divided by 2, 5 cases. This case, both the factors are similar. If I want to eliminate this one, it is a number of factors minus 1 by 2. If the question is distinct factors, distinct means both the factors should be different. If it is mentioned in the question that it is distinct, answer is number of factors minus 1 by 2. Number of factors minus 1 by 2. If the distinct word is not present, then it is number of factors plus 1 by 2. I hope the idea it is clear. 36 is 2 square into 3 square. 3 into 3 it is 9. 3 into 3 it is 9. 9, out of which 4 reverse case we have eliminated. 4 plus 1, 5. Why these minus 1 by 2 it came? I do not want to write it as 6 into 6. I do not want to write it as 6 into 6. I hope the idea it is clear. Idea it is clear. Now let us solve this question. First thing is the number should be written as a power of prime basis. Number should be written as a power of prime basis. So it is 3 square. 6 can be written as 2 into 3 power square into 5 power 4. So this is 2 square into 3 power 4 into 5 power 4. 2 square into 3 power 4 into 5 power 4. 2 square into 3 power 4 into 5 power 4. Are the variables mentioned in the question? No. If the variables are not mentioned in the question, which pair we have to take? Unordered pair we have to take. If the word distinct it is there and the number is a perfect square, number of factors minus 1 by 2. First one. In how many ways can you write a number as a product of two numbers? Product of two numbers. Nothing is mentioned. It is an unordered pair. Unordered pair means 3 into 5 into 5. These are the number of factors. If nothing is mentioned, it is a number of factors plus 1 by 2. Number of factors plus 1 by 2. Sir, why it is a number of factors plus 1 by 2? Please see the powers. Powers are all even numbers. If the powers are even numbers, then it is a perfect square. In a perfect square case, see here, in a perfect square case, Case number 2. What is the answer we got? Number of factors plus 1 by 2. Number of factors plus 1 by 2. So, first one answer is 25. 3s are 75. 75 plus 1, 76. 76 divided by 2. Answer is 38. 76 divided by 2. Answer is 38. Number of factors plus 1 by 2. Second question. In how many ways n can be written as a product of two different numbers? Distinct means different. Distinct means different. 3 into 5 into 5 minus 1 by 2. 3 into 5 into 5 minus 1 by 2. 5 5s are 25, 25 3s are 75, 75 minus 1, 74. 74 divided by 2. Answer is 37. Answer is 37. Is the idea clear? Number of factors plus 1 by 2. Number of factors minus 1 by 2. Number of factors minus 1 by 2. Next one. In how many ways can you write a number as a product of two numbers which are odd? Odd into odd, it will be an odd number. But this number is an even number. So third one answer it is 0. Third one answer it is 0. I hope it is clear. Why? Because if two numbers are odd number into odd number, I will get an odd number. But the given question it is an even number. It is 0. D. In how many ways n can be written as a product of two numbers which are even? Even numbers means this will become 2k1. Next number will become 2k2. It is equivalent to 2 square into 3 power 4 into 5 power 4. 2 square will get cancelled. So k1 into k2 is 3 power 4 into 5 power 4. How many cases? 5 into 5 plus 1 divided by 2. 25 plus 1, 26 divided by 2, 13. Divided by 2, 13. I hope the idea it is clear. Divided by 2, 13. Next one. In how many ways n can be written as product of two numbers? One of them is even and another it is an odd number. Even into odd. What is even into odd? Total cases. What are total cases? It is a perfect square. B minus of C plus D. B minus of C plus D. B how much we got? 37 minus 13. 37 minus 13. 37 minus 13. I hope the idea it is clear. I hope the idea it is clear. One, it can be written as product of two numbers, one such that one of them is even and another it is odd. Same concept we did it. Then F is a very beautiful concept. How to write a number as a product of two coprimes. Here I wanted to explain a concept to you. Now listen carefully, sir. Suppose if is a perfect square. 36 it is there. 1 into 36. 2 into 18. 3 into 12, 4 into 9, 6 into 6, 6 into 6, 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6. What am I writing? I am writing it an unordered pair. I am writing this number in an unordered pair. I am writing this number in an unordered pair. Next one, first concept is product of two numbers. Product of two numbers. I wanted to tell you another approach. Product of two numbers. So this will be, listen carefully, sir. So 36 is 2 square into 3 square. 36 is 2 square into 3 square. So this will give you the answer. Product of two numbers. 3 into 3. 9. Plus 1 by 2. Total 5 cases we got. Are you all with me? Total 5 cases we got. In that 5 cases, odd into odd. Odd into odd. It is odd number, so therefore 0. Are you all with me? Third case, even into even. even into even. Even into even means 2k1 into 2k2 is equivalent to 2 square into 3 square. 4 cancel. K1 into K2 it is 9. So these 3 plus 1 by 2. It is 4 by 2, 2 cases. Even into even, 2 cases. Listen very carefully, sir. Last one. Odd into even. Odd into even. Odd into even. 5 minus of 0 plus 2, 3 cases. These 3 cases, if you observe carefully, it is 1 into 36, odd into even, yes or no? Odd into even, 3 into 12. Odd into even, it is 4 into 9. Odd into even, it is 4 into 9. If you observe carefully, 9 is 3 square. This is 3 power 1. This is 3 power 0. 3 power 0, 3 power 1, 3 power 2. It is equivalent to total number of odd factors. It is equivalent to total number of odd factors. Odd into even can also be written as total number of odd factors. Odd into even can also be written as total number of odd factors. I wanted to explain that concept to you. That is the reason I discussed this one. So product of two numbers, variables are not mentioned in the question. It is an unordered pair. In an unordered pair, if the distinct word, here if you see, here the distinct word it is given. Distinct word means number of factors minus 1 by 2. Distinct word not there, number of factors plus 1 by 2. Number of factors plus 1 by 2. 1, 2, 3, 4, 5, 6. 5. I hope the concepts are clear. A, B, C, D and E. Any doubts are there in any of these concepts? Next one, it is a product of two coprimes. Product of two coprimes. Product of two coprimes. That we will discuss it. So 6th one, 7th one, 6th, 7th, 6th, 7th and 13th, okay. These are some of the miscellaneous questions. I'm just wondering if probably it will be a little bouncer for you if I get into an advanced level. Next class, I will discuss. So what are all the various concepts that we discussed? Let me write down all the concepts, whatever we discussed.